stationary charged particle produces an electric field. For a negatively charged particle, the field lines are directed radially inwards. For a positively charged particle, the field lines are directed radially outwards, as is shown in the diagram. A charged particle moving with a constant velocity produces a magnetic field as well as an electrical field. The strength of the magnetic field generated is directly proportional to both the velocity of the charged particle and the charge on the particle. The magnetic field is both planar and circular, as is shown in the diagram, where the blue arrow, labelled V, represents the velocity of a positively charged particle which is moving out of the page and towards the right. The magnetic field is represented by the red circle labelled B, with the direction of the magnetic field indicated by the arrows. For a positively charged particle moving into the page, the magnetic field is directed in a clockwise direction. The right-hand rule can be used as a simple method of remembering this. With the thumb pointed in the direction of movement of the positive charge, the fingers curl around in the direction of the magnetic field. An accelerating electric charge produces electromagnetic waves. This is because the acceleration of the charge distorts the electric and magnetic field lines associated with the charged particle, and this distortion propagates outwards at the speed of light. This is illustrated in the diagram, where you can see the distortion of the electric field caused by the acceleration of the particle, and the purple arrows represent the propagation of this distortion outwards. A stationary electric charge experiences a force in an external electric field. The force experienced by the charged particle will be parallel to the electric field lines. For a positively charged particle, the force will be in the direction of the electric field lines, and for a negatively charged particle, it will be in the opposite direction. A moving charged particle will experience the force in a magnetic field as well as in an electric field, due to the interaction of the magnetic field generated by the movement of the particle and the external magnetic field. For oppositely charged particles, the force will be in opposite directions. The left-hand rule is a way of remembering the relationship between the velocity of a moving positive charge, the magnetic field direction, and the direction of force on the charge. With the hand held as is shown in the diagram, the force is indicated by the thumb, the magnetic field direction is indicated by the index finger, and the direction of motion of the positive charge is indicated by the middle finger. This is easy to remember as it is simply FBI. Summary: a moving charged particle generates a magnetic field which is both planar and circular. For a positive charge moving into the page, the magnetic field is oriented in a clockwise direction. The right-hand rule is a way of working out the direction of the magnetic field around a moving positive charge. A moving charged particle experiences a force when subjected to a magnetic field. The left-hand rule can be used to determine the direction of the force on a moving positive charge in a magnetic field.